Okay, the unit circle notes. The words unit, circle, means that we have a circle. Oops. We have a circle that has a radius of 1 unit. That's what the unit circle is. A circle with a radius of 1 unit. Got it? Okay. When we look at the unit circle, we have a initial side and a terminal side. This terminal side will lie on a circle, and there will be a point where that circle intersects the terminal side. And that point is called XY. Okay. If I start at 0, 0, and I go to the right, I'm going a distance of x. And if I go up, I'm going a distance of y. And so I have formed a triangle. When I connect back to 0, 0, I've formed a triangle by going x, y, come back to home. And now we have a right triangle that we can use trigonometry with. When I ask you to find the sine of 30 degrees, that triangle would have theta right here connecting the x-axis and the terminal side of the triangle, or of the, right there. Connecting the x-axis and the terminal side. Because now I have called these sides different things, I did not call them opposite, adjacent, hypotenuse, because I called them different things. We are going to look at trigonometric values as not opposite over hypotenuse. We're going to look at them as y over r. Okay, so when we look at these values, we've got sine is y over r. Do you see how sine and y totally rhyme? Sine and y over r, okay. Cosine is x over r, and tangent is y over x. Again, the sine is y over r. Cosine is r, tangent is y over x. So when I look at the picture, the sine is the vertical part of the triangle over the hypotenuse. The x is the horizontal part of the triangle over the hypotenuse. And the tangent is the rise over the run of the triangle. Have you guys heard that before? Rise over run? Has anybody heard that before? Like, I feel like it's familiar. What is rise over run? Yeah, so if I'm thinking about the slope of this triangle and I go up y over x, that is what tangent is. Tangent is the slope of that terminal side. It's the slope of that terminal side. And then for cosecant, secant, and cotangent, we just flip, flip, flip. In this section, we're going to talk about the unit circle. So if I have a unit circle, instead of sine is y over r, what will r be if I have the unit circle? 1. So instead of sine is y over r, if it's a unit circle, sine is just y. Sine is y. Cosine is x, and tangent is still y over x, because there was no r in that. So sine is y, cosine is x. And then cosecant and secant, we just have to reciprocate y and x. So to reciprocate those, we do 1 over y and 1 over x. Those are the reciprocals. And cotangent is x over y. I'm going to go back up to this picture that I had right here. And I'm going to say that, ooh, I want somebody in here to give me a triple from geometry. Right triangle triple. 3, 4, 5. Excellent. That's the easy one. Now give me a different one. Here's some. Ooh, yeah, we're going all out over there. Who was that? Oh, Chelsea. Good job, Chelsea. What's another one? 5, 12, 13. Give me another one. Starts with an 8. There is a 15.
7.
Just count random numbers. No, it's 17. 8, 15, 17. Okay. So let's say that I am looking at 5, 12, 13. Wow. Pull it out there. 5, 12, 13. And if this was a 5, 12, 13, and y would be a 12, and that would make the radius 13, okay? Now, I want to convert this into actually being on the unit circle. So I'm going to use this 5, 12, 13 triangle, and I want to make it a unit circle triangle. What's wrong with it right now as 5, 12, 13 being on the unit circle? The radius isn't 1. How can I make the radius 1? Divide by 13. Okay, so let's divide all the sides by 13. And now this is on the unit circle. I'm going to erase one of these sides because I already have the 1. Erase the 13 over 13 there. Okay, so now we have something that is on the unit circle. And how would I find the sine of theta? Oh, how would I find the sine of theta? So this is the unit circle, so I don't even need to do y over r. How would I find it? Just y. Cosine? X. Oh, wait. Actually, write these numbers. What's y? 12 thirteenths. X is 5 thirteenths. And how about tangent? Now we find tangent. Oh, no. It's y over x. So I got to put 12 thirteenths over 5 thirteenths. This is one of your favorite things to do, I know. Instead of dividing by a fraction, we could multiply by its reciprocal thing. So we'll do, oops, wrong one. So we'll do 12 thirteenths multiplied by 13 over 5. Multiply straight across, the 13's canceled, 12 fifths. That's easy enough. Reference angle. I don't remember how much we've talked about reference angles in here. So reference angles are in each quadrant when you rotate from your initial position, you rotate to a new terminal angle or terminal side I can't talk. Here's the angle that I rotated. The reference angle is an angle that will be formed if I were going to graph. Come on, change the color. If I were going to graph right here this ordered pair, it would be a reference angle that is formed by me graphing that ordered pair. So I'm going to start at 0, 0, and to graph that red ordered pair, which direction would I go? Oops. I would go to the left, and then I would go straight up, and that gives me 90 degrees. So left, straight up, that gives me 90 degrees. I come back to home, come back to 0, 0, and my reference angle is this angle formed by the terminal side and the x-axis. It's always the terminal side and the x-axis. Because it's always the terminal side and the x-axis, it's always going to be acute between 0 and 90. So visually, I can look at that and see that it is less than 90 degrees because it's smaller than the quarter. It also has to be positive. When we talk about the reference angle, it's always going to be positive. So if I'm looking at an angle that goes this way, and my reference angle ends up being right here, even though I went in a negative direction, I still say that is a positive angle, whatever angle that ends up being. So there's some pictures here that show you where the reference angle is for each quadrant. In each quadrant, for the first quadrant, the reference angle is exactly the same as the terminal side angle. It's the exact same. In the second quadrant, the terminal side angle they show in red, and then the reference angle, I'm sorry, I said the wrong color, black, and then the reference angle is in red. In the third quadrant, the terminal angle could be the black one, but the reference angle is just that little bit past 180 degrees. And then in the fourth quadrant, if we rotate all the way around to the fourth quadrant, the reference angle is that little bit left to get to the x-axis. So let's talk about reference angles a little bit, and then really we're going to evaluate 6 trigonometric functions at each real number. So for these, there's a whole discussion in our book about how, gosh, there's like a real number right here called pi over 6, and then they take it and they bend it around the triangle, so it ends up being the measurement of the, what's this called? Circumference part, it's the arc length. And then according to that arc length, we divide that by the whole thing, and it ends up being the exact same thing as this theta right here, okay? This right here is basically telling me that the angle around my circle that I'm looking at is a pi over 6 angle, right here. That was a really short explanation, but this is really, we're going to use this as practice for our unit circle. So when I do things like that, the first thing I need to know is, what is pi over 6? In degrees. Thanks, 30 degrees. Okay. So we are going to start at 0, 0. We're going to graph to the left, or to the right some amount, then we're going to go up for some amount, and then we're going to have an ordered pair right here. We're going to come back, and that's going to be our 90-degree angle. The pi over 6, or 30 degrees, is our reference angle. And we have to find the 6 trigonometric functions at this angle. That's what takes the longest, writing that. That's what takes the longest out of everything. So if this is a 30-degree angle, what kind of triangle do I have? I have a 30, 60, 90. What's the sine of 30 degrees? Okay, so I know that the first answer is 1/2. What's the cosine? Okay, we should be yelling it out. It's radical 3 over 2. This is a 30, 60, 90. If you still need the triangle, if you know this is 30, then you put the 1 here, the 2 here, and the radical 3 here, and then you've got to solve it all. What's the tangent of 30 degrees? Okay, I kind of don't have a lot of space down there, but radical 3 over 3 is correct. And then we flip each of these. 2, this is going to be 2 radical 3 over 3. And then this one is going to be just square root 3. And those come from memorization or drawing the triangle. Now, just talking about this is actually the unit circle. So this black triangle that I drew, that's not a correct representation of the red one. Since this is the unit circle, what would actually be my x and my y value? Radical 3 over 2 and 1/2. How did Paige get that? So you're saying did this?
Yeah.
Okay. Is that how you did it? Does anybody think about that answer but not say it out loud and you got it a different way? Okay, well I got it a different way, but that's probably because I know this a little bit longer. Oh, did you get it, Taylor? The sine of theta is y. And the cosine is x. So if you already know the sine of 30 degrees is 1/2, you already know the y value. If you know the cosine of 30 degrees is radical 3/2, that's the x value. Okay? Either method is great. I just wanted to show you connecting to sine is y and cosine is x. All right, so t is now 5/4 pi, or 5 pi over 4. 5 pi over 4. Where's that? 5 pi over 4. Here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, third quadrant. So if I start at 0, 0, come on, change the color. If I start at 0, 0 and I go left, and I go down, there's my right triangle. So my reference angle is right in here. Now my reference angle for this example is going to be different than my reference angle for example A. My reference angle for example A was the exact same angle that was given to me, pi over 6. But my reference angle for example B is going to be different. It's not 5 pi over 4. It's got to be less than 90 degrees. Awesome. Just the pi over 4. So what I'm thinking about is I'm going to think about my sine, cosine, tangent, and then flip, flip, flip for a pi over 4 triangle. And pi over 4 is what in degrees? 45. So we're thinking about 45 degrees and what the sine, cosine, tangent are. But I'm not going to write 45 degrees down here. I'm going to write 5 pi over 4, and I'll tell you how that differs from just the pi over 4 answer. Sorry, this is the part that takes the longest right here. Okay, so when we talk about the sine at 5 pi over 4, or the sine at pi over 4, or the sine of 45 degrees, what do we get? It's radical 2 over 2. That is, oops, that is not the correct answer for this. It almost is. So it is going to be radical 2 over 2. The difference now is because of my triangle being in the third quadrant instead of the first quadrant, when I talk about x and y being right here, when I talk about x and y, oh my gosh. So the y value is almost radical 2 over 2. I'll put radical 2 over 2 here. Almost is. That's not the right answer. Because when I go and I graph this and I go left and then I go down, what does that do to my y value? It goes negative. So my y value is actually negative radical 2 over 2. So what's my x value? Also negative radical 2 over 2. So what's my tangent value? 1. So that's positive, isn't it? And then the cosecant and the secant, we just reciprocate sine and cosine, and the more that you've done these, the more you'll just remember that it's radical 2, but it is negative, so negative radical 2. And then cotangent 5 pi over 4, when I flip it, is still 1. Okay? All right, the next one. Now our t value is 0. So that's here. So if I go x and y, what ordered pair do I get? One, 0. That's the radius, 1, right? So if I go over 1, but I don't go up at all, we've got 1, 0. We can, even without a triangle, find the sine, cosine, tangent, and the other 3 trigonometric ratios of this 0-degree terminal side. We can find them all because we have x and y. And with x and y, you can also find tangent. So the sine of 0 is y. What's y? 0. The cosine of 0 is x, and that is 1. And then the tangent of 0 is y over x. Zero over 1 is 0. Yes. And then we flip. So cosecant of 0. What happens when I flip 0? What do I know? It is undefined. The reciprocal of 0 is undefined. Cosine, nope, secant. 0. If I flip 1, I get 1. And cotangent, 0. If I flip 0, I get undefined. Okay, next time we've got pi. So pi is on the x-axis. For the unit circle, the radius is 1. And my ordered pair would be negative 1, 0. Good. So then the sine is y. The cosine is x. The tangent is y over x. And then I'm not going to do the next 3 because it's just flip. They're the exact same answers as question C. Well, not exactly, but pretty close to the same answers. Okay? Is that okay? Moving on. Evaluate the 6 trigonometric functions at t equals negative pi over 3. So if we start at 0, 0, we go negative pi over 3, we're going to go down pi over 3. Does anybody know how much pi over 3 is as a degree? Okay, so that's about 60 degrees right there. And if I start at 0, 0, and I go right, and then I go down, that forms my right angle. That puts my theta, my reference angle, connecting my x-axis and the terminal side, even though we went this direction. The reference angle for this would be what angle? What would my reference angle be? So I'm not going to say 60 because it's in radians, and I'm not going to say negative because they're never negative. I'm just going to say pi over 3. So even though I rotated down, the reference angle is just the pi over 3 part. Like if I were going to pull out that triangle, it would still be just pi over 3 no matter where the triangle was. Okay, so we are finding everything for 60 degrees, but we have to keep in mind the quadrant it's in. Maybe I should go ahead and label this xy. So if we know the sine and the cosine, we can label the xy. Do we know the sine of 60 degrees? Radical 3 over 2. And the cosine of 60 is a half. Now let's determine if any of them are negative. If I go to the right, that's my x. If I go down, that's my y. If I go down, that's negative. So anything over here that has a y in it would be negative. To find the tangent, I could work out y over x, or I might just know the tangent of 60 degrees already because I memorized, and therefore I do not have to do any extra work. Does anybody know it? It is just square root 3. Is it going to be negative or positive, though? Why? It is negative. Why? Who was saying? Mitchell.
Oh, Will was Austin.
That's okay. He talked last time, so you tell me.
It's in the fourth quadrant, so only the y is negative, so then like a negative times a positive is a negative.
Why are you multiplying?
Because I multiply by others.
Oh, okay, because you worked it out.
Yeah.
Okay, yeah. Y over x is what tangent is. So if one of them is negative, then the whole thing will be negative. Chelsea? Yeah, but I don't really, but yeah, I'm not a gimmick person, but yeah, it is. Okay, we'll get to that. All right, then we flip each of these. So this one would be negative 2 square root of 3 over 3, and then this one would be 2, and this one would be negative radical 3 over 3. These we're just finding the sine, cosine, and tangent. So 13 pi over 6, where would that be? 13 pi over 6. So if I'm doing 13 pi over 6, I'm dividing the top part into 6. That would make 6 pi over 6 here. Got to keep going. 6 more pi over 6 will give me 12 pi over 6. Keep going. So we go to 13 pi over 6, we end up in the first quadrant. What's our reference angle? Pi over 6. And pi over 6 is a 30 degrees. So we're finding sine, cosine, tangent, pi over 6, 30 degrees. 1/2, square root of 3 over 2, square root of 3 over 3. Any of it negative? No, because the first quadrant, nothing's negative. So we're all good. Negative 7 pi over 2. So we're going negative. We're counting by pi over 2s, and pi over 2s are 90 degrees each. So 1 pi over 2, 2, 3, 4, 5, 6, 7. So I ended up on the axis. If I'm on the axis, I cannot form a triangle, but I can use my xy coordinates. What ordered pair is right there at the top of the y-axis? 0, 1. So the sine is y. Sine is y. So sine is 1. Cosine is x. So cosine is 0. Tangent is y over x. So tangent is undefined. All right, here's a couple calculator practice questions real fast. Using the calculator, evaluate the expression, round to 4 decimal places. Let's see if you guys can do this correctly. Do the first one. Pull my calculator out. It's coming. Oh, no! Yeah. Is that good? Okay.
Can we just go like tangent of 6 here, or do we need to plug in pi over 6?
So this is ask. Oh. Well. For the first one, you're going to plug in tangent pi over 3. So yes, you could convert it but like you won't be able to convert all of them, so. So now we should know the tangent of pi over 3 by hand, like in our memory, but this is asking us to round, so we're actually going to type it in. Okay, did you get approximately 1.7321? Approximately. If you didn't get that, what could be wrong? You're in degree mode when you should be in radian mode. Okay? All I typed in was tangent pi divided by 3. So to type in cotangent 1, is there a cotangent button? No. But we learned about identities. And cotangent is the same thing as 1 over tangent. And because the angle stays attached to that trig ratio, since it stays attached, we just do 1 over tangent 1. Six, 4, 2, 1. Do we know the answer for cosine 45 degrees? Do you guys know that by hand? Like by head without a calculator? Right, so what is that as a decimal? I don't know. .7071? Okay. And then secant, we can't type in secant, so you're going to use its identity. You're going to say that's the same thing as 1 over cosine 1.8. Negative 4.4014. All right, so that is 4.2. Stop the notes, gather our thoughts.